What is synchronization in Java?
Synchronization means controlling access to shared resources so only one thread can use them at a time. It prevents issues like race conditions and keeps data consistent.
Can you explain object-level locking?
Object-level locking happens when you use synchronized on an instance method or block. The lock is taken on that specific object. Other threads trying to use synchronized code on the same object must wait. Scenario: in a shopping cart project, if two threads try to update the same cart object at the same time, synchronization ensures the cart total doesn't get corrupted.
What about class-level locking?
Class-level locking is used when you synchronize static methods or blocks. The lock is taken on the class object itself, so it applies across all instances. Scenario: in a shopping cart system, if you maintain a static counter for total carts created, class-level locking ensures only one thread updates it at a time.
How does block-level synchronization differ from method-level?
Method level: the whole method is locked. Block level: only a small part of the method is locked using synchronized OBJ. Block level is more efficient because you lock only the critical section. Scenario: in checkout, you may lock only the inventory update block, not the entire payment method.
When is a synchronization block actually called?
A synchronization block is executed when a thread enters a synchronized section. At that moment, the thread acquires the lock of the object or class for static. Other threads trying to enter synchronized code on the same lock must wait until the lock is released, and once the thread exits the lock is released and another waiting thread can enter.
What is a race condition and how do you prevent it?
A race condition happens when two or more threads change shared data at the same time, and the final result depends on timing. Scenario: in a shopping cart, two threads adding items simultaneously could cause the cart count to be wrong if not synchronized. Prevention: use synchronized blocks or methods to ensure only one thread updates the shared data at a time. Alternatively, use concurrent utilities like atomic integer or concurrent hash map that handle synchronization internally. Resolution: if race conditions are already happening, identify shared resources, wrap updates in synchronized blocks, or replace data structures with thread-safe alternatives.
What is deadlock?
Deadlock happens when two threads are waiting for each other's locks and neither can continue. Scenario: in a cart project, thread A locks the cart object and waits for the inventory object, while thread B locks the inventory and waits for the cart. Both are stuck forever. Prevention: always acquire locks in a fixed order. Use try-lock with timeouts or avoid nested locks.
What is starvation?
Starvation happens when a thread never gets CPU time or access to a resource because other threads keep taking priority. Scenario: in a shopping cart system, if one thread always gets preference to update inventory, another thread may starve and never update its cart. Prevention: use fair locks, reentrant lock with true, or balance scheduling to ensure all threads get a chance.
How does complete future help in real-world scenarios?
Complete Future lets you run tasks asynchronously and combine results without manually handling locks. Scenario: in a banking app, one future debits the sender, another credits the receiver, and another sends a notification. All run in parallel and combine at the end, ensuring smooth transaction flow.
What is executor service and why is it useful?
Executor service manages a pool of threads. You submit tasks, and it handles scheduling and reuse of threads. Scenario: in a shopping cart project, each user request can be handled by a thread from the pool. Executor service ensures efficient reuse of threads instead of creating new ones for every request.
When did you face synchronization issues in a real-time project?
In a shopping cart project, we faced race conditions when multiple users added items at the same time. The cart totals were inconsistent. We solved it by using synchronized blocks around the cart update logic. Later, we optimized by using concurrent collections like concurrent hash map to store cart data, which improved performance and avoided manual locking.